Hello and welcome back. Today's session will be quite engaging as we'll have the opportunity to put our understanding of Chapter 3 to the test. It's going to be an exciting opportunity to apply what we have learned and reinforce our knowledge. I recommend that for each question you pause the video and take a moment to make your own guess at the answer. Afterwards, we can review the answer together. So let's begin. Question number 1. In a test automation project where the primary goal is to design test cases manually, but the execution and adaptation of tests are automated, which layers of the GTAA need to be utilized? The options are A. Test definition layer only, B. Test execution layer and test adaptation layer, C. Test generation layer and test definition layer, and D. Test execution layer only. And the correct answer is B. Test execution layer and test adaptation layer. So in this scenario, the primary goal is to design test cases manually, meaning that the test generation is not automated. However, the execution and adaptation of tests are automated. Therefore, you need the test execution layer to automate the execution of tests and the test adaptation layer to adapt the automated test for various components or interfaces of the SUT. These layers together enable the automation of test execution and adaptation. Now also let's have a look at the other options as well, that why they are incorrect. Option A is test definition layer only. So this option is incorrect because it doesn't address the automation of test execution and adaptation, which are required in this scenario. Then option C, test generation layer and test definition layer. This option is incorrect because it suggests automating test generation, which is not the primary goal in this scenario. It also does not include the necessary layers for test execution and adaptation. And the option D, test execution layer only, is incorrect because it focuses solely on test execution, neglecting the need for test adaptation in this scenario. Question number 2. In a software development project, you are tasked with designing test cases manually and specifying test procedures for a complex financial application. The primary goal is to ensure thorough test coverage of critical financial calculations and transactions. Which layer of the GTAA will you primarily work with in this scenario? And the options are A. Test generation layer, B. Test definition layer, C. Test execution layer, and D. Test adaptation layer. And the correct answer is B. Test definition layer. Okay, so in this scenario, the focus is on manually designing test cases and specifying test procedures. And the test definition layer provides tool support for specifying test cases, defining test data, specifying test procedures, and defining test scripts, making it the primary layer to work with for achieving comprehensive test coverage. Now let's see why the other options are incorrect. Option A, test generation layer, is incorrect because the test generation layer is primarily concerned with test case generation, which is not the primary goal in this scenario. Option C, test execution layer. This is incorrect because the test execution layer is responsible for executing test cases and logging test case execution and reporting the test results, which is not the primary focus in this context. And the last option, D, test adaptation layer, is incorrect because the test adaptation layer deals with adapting automated tests for different components or interfaces of the SUT, which is not the primary concern when designing test cases manually. Question number 3. In a scenario where the TAS must maintain compatibility with different versions of the SUT, which aspect of configuration management becomes critical? Managing test scripts. Option B, handling test adapters for the SUT. Option C, version control of test definitions, specifications, including test data, test cases, and libraries. And option D, managing test execution engines and supplementary tools and components. And the correct answer is option C, version control of test definitions / specifications, including test data, test cases, and libraries. Okay, now let's have a look at the explanation. So to ensure compatibility with different SUT versions, it is crucial to manage the configuration of test definitions and specifications, which includes test data, test cases, and libraries. So these elements constitute the core of the testware and must be version controlled to align with the SUT's version effectively. Also now let's have a look at why the other options are incorrect. So option A, managing test scripts. This is incorrect because while managing test scripts is important, it is not the primary focus for ensuring compatibility with different SUT versions. Then we have option B, handling test adapters for the SUT. This one is incorrect because managing test adapters is important, but it is not the key aspect for version compatibility with the SUT. And option D is managing test execution engines and supplementary tools and components. This option is incorrect because while managing test execution engines and tools is important, it is not the primary concern for ensuring compatibility with different SUT versions. Question number 4. When designing the test generation layer of a TAA, what critical factor should be considered in selecting a test generation strategy? Option A, selection of the test execution tool. Option B, selection of requirement-based or scenario-based test generation. Option C, choosing the test selection strategy. And option D, selection of style guides and guidelines for the definition of high-quality tests. And the correct answer is option C, choosing the test selection strategy. Okay, so the effectiveness and efficiency of a testing process often depends on the strategy which is used to select the test. So different strategies may prioritize different aspects of testing, such as code coverage, risk assessment, or specific use cases. Now let's see the other options and like why they are incorrect. So option A is selection of the test execution tool. So this option is incorrect because it focuses on test execution layer, not the test generation strategy. Option B, selection of requirement-based or scenario-based test generation. So this option is incorrect because it addresses the type of test generation strategy but does not specifically consider the test selection strategy. And then option D, selection of style guides and guidelines for the definition of high quality tests. This option is incorrect because it pertains to guidelines and quality criteria for test definition, not the test generation strategy. Question number 5. In a test automation architecture TAA, what is a significant benefit of using higher levels of abstraction? Option A, improved performance of the TAS. Option B, reduced initial investments and lower skill set requirements. Option C, increased flexibility for further evolution of transitioning to new approaches. And option D, simplifies access to test interfaces of the SUT. And the correct answer is option C, increased flexibility for further evolution of transitioning to new approaches. So high levels of abstraction in a TAA provide increased flexibility for future evolution or transitioning to new approaches or technologies. So while this flexibility is advantageous, it comes at the cost of a larger initial investments and potential trade-offs in performance. Now let's have a look at the other options and see why they are incorrect. Option A, improved performance of the TAS. So this option is incorrect because higher levels of abstraction may lead to lower performance of the TAS. And option B, reduced initial investments and lower skill set requirements. This option is incorrect because higher levels of abstraction typically require larger initial investments and may necessitate higher skill set requirements. Then we have option D, simplifies access to test interfaces of the SUT. This option is incorrect because abstraction primarily focuses on flexibility and technology independence, not necessarily simplified access to SUT interfaces. Question number 6. In the context of a TAA, what is a central consideration for automated test execution? And the options are A. Performance at the software level, B. Availability of test interfaces at the API level, C. Interactions with the SUT via protocols, and D. Interaction with SUT services at the service level. And the correct answer is option B. Availability of test interfaces at the API level. So in automated test execution within a TAA, a central consideration is the availability of test interfaces at the API level. This level involves invoking functions, operations, or methods provided by a remote application programming interface. Now let's have a look at the other options which are incorrect. Option A, performance at the software level. This option is incorrect because the focus here is on the availability of test interfaces, not performance. Option C, interactions with the SUT via protocols. So this option is important but relates to a different level of interaction, not specifically the central consideration for automated test execution. Similarly, option D, interaction with SUT services at the service level, is also incorrect because it pertains to a different level of interaction within the SUT, not specifically the central consideration for automated test execution at the API level. Question number 7. In a test environment where the TAS simulates or emulates the SUT environment, what is a suitable example of such a test setup? Option A, a computer with both the SUT and the TAS for testing software applications. Option B, networked test devices to emulate the operational environment of the SUT for testing network routers. Option C, simulators to simulate the physical environment of the SUT for testing embedded control units. And option D, individual networked computers for the SUT and TAS respectively for testing server software. And the correct answer is option B, networked test devices to emulate the operational environment of the SUT for testing network routers. So in a test environment, using network test devices to emulate the operational environment of the SUT is suitable for testing network routers. So this setup allows for testing the software of a network router while emulating the conditions it would encounter in its operational environment. Now let's see why the other remaining options are incorrect. Option A, a computer with both the SUT and the TAS for testing software applications. This option is valid, but it doesn't specifically address the emulation of the SUT environment, and it is more suited for testing standalone software applications. Option C, simulators to simulate the physical environment of the SUT for testing embedded control units. This option is also valid, but it relates to testing embedded control units and their physical environment, not network routers. Option D, individual networked computers for the SUT and TAS respectively for testing server software. So this option does not specifically address the emulation of the SUT environment, and it is more suited for server software testing. Question number 8. What method for estimating time and complexity of a TAA design involves using expert estimation or historical data? And the options are A, work breakdown structures. Option B, parametric estimation. Option C, size-based estimations. And option D, group estimations. And the correct answer is parametric estimation. So parametric estimation involves using expert estimation or historical data to estimate time and complexity. It is a method that relies on parameters and relationships derived from past projects to make estimates. Option A, work breakdown structures, is the incorrect option because it refers to estimating by breaking down tasks into smaller components and is not primarily based on historical data or expert estimation. Option C, size-based estimations, is also incorrect because this option focuses on estimating based on the size or scale of the project components, for example, function points, story points, rather than historical data or expert estimation. Option D, group estimations. So this option involves collaborative estimations, but it doesn't specifically rely on expert estimation or historical data. Question number 9. What are the primary benefits of structured scripting in test automation? And the options are option A, reduced cost of automating new tests and simplified script management. Option B, lower initial investment and minimal programming skills required. Option C, increased volume of scripts and reduced maintenance changes. And option D, efficient script documentation and improved naming conventions. And the correct answer is option A, reduced cost of automating new tests and simplified script management. Okay, so the primary benefits of structured scripting in test automation include a significant reduction in the cost of automating new tests and simplified script management due to the organization of reusable scripts in a script library. Okay, let's see why the remaining options are incorrect. Option number B, lower initial investment and minimal programming skills required. Okay, this is incorrect because structured scripting may require high initial investment in creating reusable scripts, and programming skills are also required for script development. Option C, increased volume of scripts and reduced maintenance changes. So structured scripting does not inherently increases the volume of scripts, rather it reduces the effort needed for maintenance and allows for script reuse. Option D, efficient script documentation and improved naming conventions. Okay, so script documentation and naming conventions, they are important in all scripting techniques, and they are not like specifically a primary benefit of only structured scripting. Question number 10. What is a key consideration in TAS development with regard to compatibility and synchronization with the SUT? Option A, TAS development should ignore SUT related considerations. Option B, TAS development and SUT development should have separate life cycles. Option C, TAS development should focus solely on test script creation. And option D, TAS development should ensure compatibility and synchronization with the SUT. And the correct answer is option D. So TAS development should ensure compatibility and synchronization with the SUT. So the TAS needs to be aligned with the SUT's characteristics, interfaces, and changes to effectively automate testing. Let's have a look at the other options and why they are incorrect. Option number A, TAS development should ignore SUT related considerations. So this option is incorrect because ignoring SUT related considerations would hinder the effectiveness of test automation. Option B, TAS development and SUT development should have separate life cycles. This option is also incorrect because TAS development and SUT development should align and interact to ensure effective testing. Option C, TAS development should focus solely on test script creation. So this option is incorrect as well. While test script creation is a part of a test development, it is not the only consideration. Compatibility and synchronization with the SUT are also very crucial. Question number 11. What is one of the primary challenges associated with model-based testing? And the options we have are option A, model-based testing tools are not yet mainstream. Option B, model-based testing allows for efficient test execution. Option C, model-based testing does not require any adjustments to the existing test processes. And option D, model-based testing does not require modeling expertise. And the correct answer is option A, model-based testing tools are not yet mainstream. Okay, so as mentioned over here, model-based testing tools are not yet mainstream and they may not be as widely adopted as other testing approaches. Option B, model-based testing allows for efficient test execution. This is incorrect because model-based testing primarily focuses on test case generation, not execution. Option C, model-based testing does not require any adjustments to the existing test processes. This option is also incorrect because model-based testing often requires adjustments to existing test processes. And option D, model-based testing does not require modeling expertise. This is incorrect because model-based testing typically requires modeling expertise to create effective test models. Question number 12. Why is it recommended to leave some test interfaces in the SUT prior to the product release? And the options are: option A, test interfaces are essential for SUT performance optimization. Option B, test interfaces help prevent security risk. Option C, test interfaces can be used for problem diagnosis and testing maintenance releases. And option D, test interfaces simplify the SUT architecture. And the correct answer is option C. Test interfaces can be used for problem diagnosis and testing maintenance releases. It is recommended to leave some test interfaces in the SUT prior to the product release because these interfaces can be valuable for a problem diagnosis and for testing maintenance releases. And they also allow service and support engineers to diagnose issues and test updates or patches. Option A, test interfaces are essential for SUT performance optimization. This option is incorrect because test interfaces primarily serve diagnostic and testing purposes, not performance optimization. Option B, test interfaces help prevent security risk. This option is also incorrect because while test interfaces should not pose any security risk, but they do not actively prevent security risks. Option D, test interfaces simplify the SUT architecture. This option is also incorrect because test interfaces are added for diagnostic and testing purposes, and they may not necessarily simplify the SUT architecture. Question number 13. Why is technology compatibility between the TAS and the SUT important from the beginning of development? Option A, it simplifies the TAS development process. Option B, it eliminates the need for TAS testing. Option C, it ensures a seamless interplay between the TAS and SUT. And option D, it reduces the need for process synchronization. And the correct answer is option C. It ensures a seamless interplay between the TAS and SUT. Even if complete compatibility is not initially achievable, planning for technology compatibility and considering adapters or intermediaries can help facilitate interaction between the two systems. Option A, it simplifies the TAS development process. This is incorrect because while technology compatibility can streamline integration, it does not necessarily simplify TAS development, which may involve complex requirements. Option B, it eliminates the need for TAS testing. Okay, so technology compatibility does not eliminate the need for TAS testing, as testing is essential to verify the functionality and integration of the TAS with the SUT. And option D, it reduces the need for process synchronization. This option is also incorrect because technology compatibility does not reduce the need for process synchronization, but can aid in effective synchronization between TAS and SUT development processes. Question 14. Imagine you are a test automation engineer working on a project with multiple SUT configurations. Each configuration requires specific TAS adjustments. Which approach should be employed to handle this variability effectively? Option A, maintain a single TAS version with different configuration profiles. Option B, create a separate TAS instance for each SUT configuration. Option C, develop custom TAS versions for each SUT configuration. And option D, use TAS parameterization to adjust the TAS to different SUT configurations. And the correct answer is option D. Use TAS parameterization to adjust the TAS to different SUT configurations. So using TAS parameterization allows you to adjust a single TAS to different SUT configurations effectively. Parameterization enables the TAS to adapt its behavior and settings based on the specific configuration requirements, eliminating the need for multiple separate TAS instances or custom TAS versions for each SUT configuration. Okay, let's have a look at the other incorrect options. Option A, maintain a single TAS version with different configuration profiles. So this option is incorrect because this option suggests maintaining different profiles within a single TS version, but it doesn't provide the same level of adaptability as parameterization. Option B, create a separate TS instance for each SUT configuration. This one is also incorrect because creating separate TS instances for each configuration can lead to complexity and maintenance challenges, especially if there are many configurations. And option C, develop custom TS versions for each SUT configuration. So creating custom TS versions for each configuration can be resource intensive and hard to maintain as the number of configuration grows. And the last question, question number 15. During the TAS development process, the team realizes that certain TAS features need to be adjusted or added to accommodate new SUT configurations. What should the team consider regarding these TAS features? Option A, adjust TAS features only during TAS development. Option B, implement the features and forget about further adjustments. Option C, continuous consideration and efforts to revise, add or remove TAS features as needed. And option D, notify the SUT team to align their configurations with TAS features. And the correct answer is option C, continuous consideration and efforts to revise, add or remove TAS features as needed. Okay, so TAS features should be subject to continuous consideration and efforts throughout the TAS lifecycle. So this approach allows for adjustments, revisions, additions, or removals of TAS features as needed to accommodate new SUT configurations or changing requirements. Okay, now let's have a look at the other incorrect options. Option A, adjust TAS features only during TAS development. Okay, so limiting adjustments to the TAS development phase may lead to inflexibility when new configurations arise. Option B, implement the features and forget about further adjustments. So ignoring further adjustments can result in a TAS that become less adaptable over time and may not meet evolving requirements. And option D, notify the SUT team to align their configurations with TAS features. So while communication with the SU team is important, it's not a substitute for continuous TAS feature adaptation. TAS adjustments should consider both TAS and SUT aspects. Okay, so that wraps up our practice question session for chapter 3. I hope that you all are feeling confident now and ready to proceed with chapter 4 in the next session. If you have any lingering doubts or questions, please ask in the comment section. I'll be with you in the next session. Until then, happy testing.